Let me share our vision of the technological capacity and opportunities for the decarbonization of the Russian power sector. But first, let me share a few words about this institute, Energy Research Institute of the Russian Academy of Sciences, along with the Economic Forecasting Institute. We both belong to the Russian Academy of Sciences, and we have dealt for more than 30 years with methodological and analytical support for developing long-term strategies for the energy sector. Therefore, we've been active in the development of strategic policies, national energy strategy, long-term development plan for the gas industry, and other plans you are seeing on the screen. We are active in international collaboration, discussing methods, models, and most importantly, results of those efforts. And we've been quite active working with Russian or international power sector companies, fuel companies. In doing our quantitative forecasts, we rely on scanner. This is a set of models, several-tier set of models for forecasting, starting from the international global market forecasting, and we regularly publish the forecasts of global and Russian fuel and energy markets in close connection with the economic development scenarios, detailing down to individual sectors or regions, which allows us to make assessments and forecasts of the future consumption. And all of these will be used for developing the strategies for optimizing various sectors, power sector, gas, oil, you name it. And those sectoral development scenarios are interconnected and harmonized as part of the total energy balances, of course. And no less importantly, they are harmonized inside every sector with the financial and economic potential to provide for the optimum investments to be made looking ahead for 20, 30 years. And the final portion of this characteristic as to how much exactly we should invest in the power sector and how much it would be reflected back to the economic analysis to know if it is affordable for the Russian national economy and what would be the impact on the economic growth rate and the well-being of the population, according to what we heard during the plenary session. Today, I'm only going to focus on the power sector because decarbonization, in decarbonization, the power sector is the key, and many things are happening there. The problem of developing Russia's power sector in the constraints of hydrocarbon constraints or regulation is nothing new for us. The first time we started to systemically study that at this institute was 10 years ago as part of the then Kyoto Protocol. We were making studies of the impacts of potential constraints on the economic development overall and the development of individual sectors. Well, now, this very year, we are having a new iteration of the same studies, and I'm going to share you the results of the studies we have concluded. Very hot news indeed. Some of them are still work in progress, so I'm not going to share everything at all. As we discuss the power sector, we're looking at a wide range of technologies, both low-carbon technologies in gas generation and carbon capture, as well as non-carbon technologies relying on nuclear, renewables, hydro, and other sources. and our basic approaches includes three levels or tiers. First, that's the conventional economic analysis of efficiency and competitiveness of various technologies, which is based on the LCOE analysis, as well as LACE analysis, carbon avoided costs, which reduces the range of potential alternatives down to the most efficient and competitive options within the constraints from the scenario. The second tier is a conventional one too. That's the least cost capacity expansion, based on conventional big models, while taking into account, among other things, of various cost factors, various constraints on carbon emissions, which gives us a very different structure in terms of the power plant capacities and the generation output. And the last but not least is the third tier, which is where we make an assessment of economic consequences, trying to compare the required investments to be made in the power sector under whatever scenario with the potential for financing those investments by the power sector companies and the sector as a whole under various combinations of external pricing constraints and scenarios. And that's what gives us an important insight into the financial feasibility of the wishes and intended pathways, as well as expectations, which is very important. It is very important to know what would be best of all to be done, and then to know if it is feasible here and now or 10 years down the road, as the situation changes in the power markets. Talking about the Russian power sector, it is important to mention that from the perspective of carbon intensity in generation, the Russian power sector looks pretty good. It was good back in the 1990s, becoming even better in 2017. And the giant effort that the European Union had done for technologically redoing their power sector only allowed them to get closer to the Russian indicators of carbon intensity. The reasons for this are two. First of all, as opposed to all other countries in the world, the Russian power sector has gas as a key source of energy, gas, not coals. And you see the different shares, how different the shares are of gas versus coal in Russia as opposed to the rest of the world. And there's enough, but there's still a huge room for further improvement of the carbon intensity, and that is because the existing fleet of generating equipment has features quite a low efficiency, and much can be done to improve that. Another area of improvement is Russia is a cold country, you know, and heat is no less important in Russia as electricity. So there are quite a few power plants that are based on cogeneration since long ago in Russia, which makes fuel efficiency much better, while quite a lot of heat is generated at boiler houses, at boiler facilities, which is another venue for improving the thermal efficiency, and the CO2 emissions could be reduced. And a quarter of resources produced to generate electricity, a quarter of them are non-carbon. That's a growing segment, and a lot will depend on that in the future. So speaking about the potential range of technologies for putting through the decarbonization, we mean gas generation and state-of-the-art nuclear technologies and hydro and renewable technologies as well. As for thermal generation, there is room for improvement, a large room for improvement, but anyway, whatever happens, any thermal power plant would be emitting carbon, whatever they do, whatever you do with them. So the only radical solution would be carbon capture to be introduced, but that's not much depending on the cost of those carbon capture techniques, but the cost of transportation and burial. Given the distances in Russia, those costs would be much higher than in Europe. As for the nuclear power, the situation is really unique. Russia has the full cycle of nuclear generation and that's a significant competitive advantage, allowing to expect a competitive and inexpensive nuclear power sector, which we were discussing in the morning. The cost of nuclear units, not the main ones, but is estimated at about $2,000 per kilowatt, which is quite comparable with what nukes cost in China, South Korea, $2,500 per kilowatt. And the reason for that is, on the one hand, the differential cost of labor and part of the materials as well. And there's another important factor. In Russia and all countries that I mentioned, the nuclear power development has been quite intense. And this effect of building more and more better and better nuclear units makes this sector much less expensive. But in Europe, for instance, the costs also include the costs on restoring the competences that Europe used to have, and then those competences started to degrade. And of course, you need to incur lots of costs. The cost of nuclear power plants in Europe used to be, well, relatively not high in the beginning of the construction, but a project would take 10 to 15 years, and every time you recalculate it, the cost grows, sometimes several-fold. So those pent-up investments in Europe are pretty high. With hydropower, the potential is high, but again, huge hydro resources are located in the eastern part of the Russian Federation, while the demand is mainly in the European part of Russia. Of course, there are projects that capex-wise could be quite attractive, not all of them, of course, but again, there are some additional costs to incur, quite large ones, because a large-scale energy construction needs to be invested to connect the eastern and the Asian and the European parts of Russia. The renewables are a growing sector, and already looking at the recent biddings, the cost of wind or solar electricity is relatively good. Indeed, there are some issues or problems with this sector lacking the respective manufacturing industry to produce things domestically, unless we want to import everything. So investments are required there. To what extent it is competitive, that is a controversial question. On the one hand, projects that are being implemented in the European part of Russia feature the utilization rate that is not really high. And again, there's a problem of availability of capacities from the renewables whenever you need it, not when the wind is blowing. And that again requires additional costs for building redundancies. There are better resources but they are located far away, which means significant investments in the grid, which may be required under certain extreme scenarios, but that necessitates an additional assessment that would have to be done if we're talking about the total decarbonization. Now we're talking about smart decarbonization or moderate decarbonization that was mentioned in the morning session. And we agree, of course, that the top priority amongst the technologies to reduce, not to bring to zero the carbon emissions, that's gas generation, the least cost low carbon technology, and nuclear technology coming next. You see from this chart how much is the difference in the costs. Of course, looking ahead for the next 2 decades, expecting a serious progress in technological development with the capex getting lower for that sector, which could get closer to the costs of the gas generation or maybe even outstrip that. And nuclear power plants or even wind generators could become more efficient, but that only if we do not take into account the additional costs for integrating those in the single energy system, and such costs could be pretty high. We have made a parametric analysis of the impact on the cost of electricity from the renewables if that effect should be taken into consideration, which is the right thing to do, because it is economically correct to compare technologies that are equally attractive for the consumers. In this case, for the power grid, availability is exactly that. Speaking now about the structural options or the generation mix in generation by 2050, that's the kind of analysis we did. We used our own tool, this model that does the optimization of the future balances of electricity and heat, given the constraints on carbon. If that option should be taken into account, carbon regulation introduced, or with introducing various pricing levels on the carbon, if it is a pricing-based regulation to be introduced. And these are the brief results. Forgetting about the carbon regulation in the power sector, then by 2050, inevitably, we will face the scenario of the growth in the absolute emissions of carbon relative to the current, to the threshold period that is not 1990, but 2018. It could be 12 to 30% as a growth rate, and that will heavily depend on how successful the technological improvement program in the nuclear sector that Rosatom has already announced. If we limit ourselves with the corporate strategy of Rosatom, then most of the growth in electricity will come from gas generation. If Rosatom is going to be more ambitious and technological perfection, then indeed the nuclear generation could become a serious competitor to gas generation. Then there would be a moderate dynamics of carbon emissions growth. But we're not interested in carbon emissions growth. And we made a parametric analysis where we fixed the level of carbon emissions from the power sector as of 2018, And there are three scenarios that we have considered, each with its individual rate of success of the development of the nuclear generation. If it is really successful as they wish to, then the nuclear generation becomes the key non-carbon-based technology to develop the power sector if the emissions are really curbed. If the level of success is more moderate, economically, capex-wise, then they would compete with gas. And not very large, but significant niche appears for the renewables. Again, if we make the carbon regulation more stringent, down to 80% of the rated level, 2018 level, then inevitably a serious transformation of the entire generation mix should happen, with coal generation going significantly down and replacement of part of gas generation with nukes or renewables, especially if the nuclear generation is somehow limited in its development rate. The nuclear generation and renewables are part of the heat supply as well, where sometimes we already see the transition to the situations where we use electrical generation facilities used to generate heat as well, dropping fuels. If we introduce the emissions charges at $20 per ton or $100 per ton by 2050, and the situation would look controversial then. On the one hand, if we're going to limit the development of the nuclear generation, then we don't have many options for interfuel competition. Actually, we would be in a situation where gas remains in the center of generation with some share of renewables. But the volume of emissions relative to 2018 would not be there if the nuclear generation gets an opportunity for successful development. Then, indeed, we can expect a certain reduction, if not large, of the emissions. If this charge is established at $100 per ton, not overnight, but closer to 2050, then more interesting structural changes and more costly changes could occur if the nuclear generation is constrained. Then at that kind of carbon costs, there would be more effective opportunities for the renewables to grow further and further. It is already close to 12%, but if the nuclear power plants will develop in a more intense way, then there would be a better balanced structure where the nukes are the key non-carbon technology, but the renewables would not be brought down to zero. They would be quite influential in certain areas. And the final third tier is where we move away from the optimum development plan vis-à-vis the required investments, and we try to assess what it would be like from the perspective of the required electricity pricing. So this is a conventional financial plan, cash flow statement, forecast of the flows of capital and market revenues, whatever income statements, sustainability analysis. So this is quite a simple but easy to use and clear analysis using various options or scenarios pertaining to carbon regulation and pricing policy and economic policies overall. And based on these, we can look at the balance, if there is a good balance between the investments, between the desired development and the required investments. How much electricity should be in order to implement certain scenarios based on own resources or borrowed funds, while providing for the minimum required financial sustainability. Quite frankly, we have not finalized the financial analysis so far, but we have another smaller scenario where I can share the results already now. And this makes you think that indeed an option, if you opt for decarbonization, then you are bound to face certain periods of time where the pricing policy would have to change. That comes at a price, and the price is quite high. Probably sometime by 2050, the growth of price would start to be made up for with the price going down, but in the medium term, the price risks would be high. For instance, we looked at the situation where the share of the renewables is up to the target 5%. You remember the target of 2009. Then, if that happens, by 2035, the additional price growth in real terms would be nearly 9%. That's about 1% over the inflation rate per annum. And this is only at 5% of the renewables in the total. Of course, if it is a good mix, share it half and half between the growth of the renewables and the growth in the nuclear generation, then it will be smooth. It would be smoothed out, and then in 2030, that the price rise would be not significant. If we redo the power sector structure in a more ambitious way, relying on non-nuclear and renewables, then we need to expect the price surges that could last for 5 to 10 years at the very least, with potential improvement of the pricing situation much later on. About 6 weeks later, I will be ready to share the final results of this. Thank you. Thank you. Quite a lot of very interesting figures.
Thanks a lot, Andrei. My name is Georg Zachmann. I work at Bruegel, a think tank in Brussels. That's really a fascinating discussion on the electricity sector perspective of a country that, as Georgi Popov mentioned, already has relatively low carbon footprint and still, as we have seen also in the last presentations, great future development potential. So thank you very much for that. I would have 3 questions on the impact of some global trends on the development of the Russian electricity system. So the first question is, we see gas import demand in the EU declining potentially, and we see pressure on global gas markets. So potentially Russia might be able to export less gas in the future. So is there a potential that Russia will use more gas domestically and replace some coal domestically in order to make use of this valuable fuel? The second question is, and some of your colleagues mentioned that, there is a declining cost of renewables and there is a relatively high flexibility of the Russian power plant system. So you have a lot of natural gas power plants in the country already. You have a lot of hydropower. So is there potential in kind of using the Russian electricity system also as a flexibility provider, not only for domestic renewables, but potentially also for renewables in neighboring countries? Because my understanding is that flexibility is one of the big values in the electricity systems of the future. And the last related question is, We see some discussions ongoing on the UPS synchronized grid and how it will develop in the next decades. So there is some question about whether some countries might decouple from that. And is there some thinking in Russia about how to still keep a cross-border electricity trade, maybe with DC links or with other options, to make essentially use of the flexibility that the Russian system can provide and monetize? Thank you very much for this fascinating discussion.
Спасибо. У нас Федор Веселов готов ответить.
Thank you. Fedor Veselov is ready to take up these questions. Yes, thank you very much for the questions. Your question number one, gas versus coal. Well, the situation with gas could vary. This year, exactly, we're going to look at various scenarios of changing demand for gas in various markets, how much gas and at what price we could be able to offer as a conventional resource. But there are other options of how the gas sector should adapt to that. For instance, it is possible, and that's a serious option, it is possible to make the gas sector the producer of not only natural gas, but also hydrogen, so that gas and hydrogen mixture would be supplied, or maybe pure hydrogen. Gazprom has been actively working on techniques on pyrolysis to produce hydrogen and some other techniques. Another direction would be a replacement of coal or motor fuel with gas. Within a certain reason, there are economic reasons for doing that, because it should be economically efficient. It shouldn't cause additional subsidies to be paid, correct? This is still a market economy, isn't it? Subsidies are many and heavy as they are. Well, then, reduction of coal consumption would mean reduction of the output in the coal sector, which could cause social problems, societal problems, and the coal sector would have to be adapted for that. So this is a multifaceted picture that we're looking at. Basically, the gas sector is actively working on finding the ways to get adapted to the new reality, new pricing reality internationally, the cross-border regulation, and to finding a good place in the domestic market as well. As for the renewables, indeed, they grow in our scenarios as well. I would look at our scenarios as extreme scenarios because they are very different in terms of their assumptions. And mind you, we indicate not the capacity mix, but the generation mix in our scenarios. If we look at the utilization rate, which is much lower with the renewables, but if you look at the installed capacity, in our scenarios, the share of the renewables, of course, depending on the scenario, could be anywhere from 10 to 15 to 20 to 27%, which is in certain cases close to the 30% mentioned by someone before me. And this is indeed a matter of flexibility in regulation. And that's a common problem. Europe has already faced it, and they struggle, as far as we know, they struggle in addressing that, and they spend a lot. Actually, the Europe plan is a plan of investment in the grid, and that has been the case since long ago. But that is because the distances in Europe are much shorter than in Russia. So you need to understand that. You need to know what is the cost of grid flexibility or grid maneuvering in Russia. That is a significant constraining factor for making the renewables flexible. And of course, we have an opportunity of being flexible with thermal generation. Of course, part of it will always remain as a reserve, but still it will be operational. even if we have many solar stations operating when there is sunshine, or we would have to build storage stations, which means more costs. And these all are factors that restrain the development of the renewables. I'm not saying there is nothing there for the renewables. Sometimes it's a necessary solution. Finally, the flexibility again. There's another problem there. Not every station could quickly respond to the changing needs. So whatever we say, we need to develop the storage systems anyway. As for hydrogen, that's again controversial. The excessive resources of the renewables would produce hydrogen. What happens to it next? It should get back to the system using some other technologies. So parallel to that, we should develop fuel cells or other technologies where hydrogen would be used to generate electricity. Otherwise, it would be additional demand for producing one more energy resource to be used on transport or in manufacturing industries. So we need to be very clear as we speak about the final goal of using hydrogen. Finally, integration. That's an old problem, an age-old problem. We keep talking about that, but that's an expensive problem. Back 15 years ago or so, the project of integration with the European power sector was thought about, and we looked at the benefits and costs of that. The point is not to build a sufficient amount of plants. We need to synchronize not only on hardware, but also on standards and regulations, and that is a much more difficult task to address. As for DC synchronization, it is already there between Russia and Finland. On AC, we still do trading with the Baltic states, but unfortunately, our relationship with the European Union is heavily politicized, and the Baltic states' decision to move to the synchronization area with the EU rather than Russia was a political decision, which was not economical. There are some economic reasons, perhaps, for that, but mostly it's politics, political constraints, and I'm not sure that they're going to go away anytime soon. Thank you. Anatoly Kopolov. Yes, I have a question to two speakers who touched on the prospects of the development of nuclear generation. Fedor Veselov gave a figure of the specific capex when building nuclear plants at $2,000. Where it comes from, this estimate? Because based on the volumetric data on the capex of building nukes abroad, at least those done by Rosatom, $2,000 per kilowatt, it doesn't add up, according to my calculation. 10, 12 years ago, I read an article on the American power system where in Florida, they dropped the idea of building a nuke because its capex grew by 20% to the budget estimate to reach $10,000 per kilowatt of installed capacity. Could you give me the source of that data? I can respond. It's simple. The source data come from the design data. Those are design data from our institutions, coming from Rosenergoatom for strategic planning, and they correlate well with the investment program of Rosenergoatom. So this figure is a piece of actual design information from actual designs that we use to build nuclear plants in Russia, not abroad. Indeed, the economics is different between Russia and abroad. Compared with even Rosatom projects done abroad, not in quantity, but as one-off projects. And also it takes into account we have a relatively simple regulation of these things, while internationally the regulation can be very difficult and burdensome, which makes the cost go up. And again, talking about other countries, nukes get more expensive just because a project takes 10 years to build. And of course, every time you rebudget it, it gets more and more expensive. Europe has been watching this for over 20 years. Initially, they are expensive, but not that expensive, but they can become several times more expensive. So the Americans are just poor builders. Is that what you say? The Americans stopped building many nuclear stations. When you do this, when you make an interruption, then it means you are bound to have higher costs.